Okay, so today I'm going to be talking to you about the impacts of climate change on ecosystem structure and function. This was the title of the research paper that I was assigned to read for Ecology, also BY222. And so let's get into it. So first off, what is climate change? The paper I looked at focused heavily on a lot of the main concerns and main impacts that we've seen since climate change has been kind of sped up since about the 1800s from humans. It is a natural process, but like I said, it's been sped up a lot by humans. You know, the burning of fossil fuels during the Industrial Revolution has only seen that, process exacerbated. Or so um, like I said, what is climate change? It's the long-term changes of weather patterns and the temperature of the planet. So our planet Earth is heating at an incredible rate. We've seen this heating process sped up ever since the 1800s when we did start burning fossil fuels more regularly. And I think a big question we need to ask ourselves as humans is how can we slow this process down? And I have listed there change our habits. And as easy as it sounds, um, enough people on a global scale have to do it for it to actually have a massive impact. If just, for example, one country out of the entire world is just deciding to fully go green and not burn any more fossil fuels and all that stuff, it's not going to be enough of an impact for the entire world to notice. The entire world as a whole has to start looking into different cleaner options to make sure that we can slow this process down. I don't think it's possible to completely reverse it, but if we can slow it down, then it'll have a massive impact. Another huge topic of discussion in the last few recent years has been the research in MOFs, which are metal organic frameworks that are used to capture molecules. So these metal organic frameworks can actually be used to capture these greenhouse gases like methane and carbon dioxide and others. And they can then be stored anywhere, similar to how we kind of just store nuclear waste underground. These moths can be used and captured and stored underground. And currently, there's research going on how we can then use this captured greenhouse gases to be converted into more useful processes. So that way, it's not just waste sitting underground. We can actually continue to recycle these greenhouse gases. So that way, if this rate of burning fossil fuels does continue, then at least we have a process to where we can make it clean. So that way, it's not affecting the atmosphere as much. So my paper covered 7 main points. Those were the climate effects on sea ice, lakes, and coastal ecosystems, biome shifts, ecosystem state change, forest growth, the mortality of pests, and then wildfire, the impact of winter warming due to climate change, and the intensification of the hydrologic cycle and feedbacks from the ecosystem on the climate. So basically, the paper was going over all these different points on how, basically as a whole, how we've observed climate change and how it's affected the ecosystems around the world. It also addressed the US as well. And it showed how a lot of the United States' ecosystems are shifting from, if they're boreal forests or if they're more, they're cooler climates, they're starting to shift towards a more temperate climate. And then same goes for those ones that are already temperate. They're starting to switch to more dry and arid conditions. And then, like I said, addressing the wildfire, any areas that are already dry, they're only getting drier, and then that leads to more wildfires. So it just goes to show that the heating of the planet has taken a massive toll on, I mean, not just the US, but the entire continent and then the entire world as a whole, because we can observe that even these slight variations in temperature, it can cause even the smallest of changes, which then kind of trickles in through the food web of different ecosystems, and then this can cause massive amounts of deaths due to one specific species not being able to live, and then it's like a trickle down effect. So some of the biggest impacts that we've observed from climate change so far has been the shift in biomes. Like I said, one of the research diagrams in the paper showed how the U.S. will look by like 2100, and it was kind of just showing how it's shifting more away from that temperate um, that temperate climate, and it's shifting more towards drier climates, just due to the fact that if the planet's heating up, there's going to be less precipitation naturally, and as it heats up more and more, then there's going to be less and less water to cycle back through the ecosystem, through the water cycle. And then even more so with the planet heating up, more ice and snow is going to start to melt, and then that's going to constantly cause, like, I don't want to say massive flooding, but it's going to constantly cause um, loads of nutrients and sediments from the soil to constantly be deposited in large quantities at once. And it's going to leave certain areas of the ecosystem completely dry and void of these nutrients when they need them, when it trickles in slowly from naturally flowing streams rather than flooding. Um, and then that leads on to my next point: population death. So if these sediments and nutrients are constantly, being forced through, or in another case, if ecosystems are now being deprived of these sediments and these nutrients, it can have massive changes to, bodies of water that are in those areas. If this many contaminants and sediments are being deposited into one large lake, for example, from a flooding river, it's going to drastically change the pH, on that scale, and that's going to cause massive population death because, let's say, for example, the fish are not going to be able to handle this quick change because they've been so acclimated to, the gradual, somewhat held constant climate that they've been living in for so many years. Um, again, touching up on the fact that the planet's heating up, more ice and snow is starting to melt, and this is only going to lead to rising water levels. Some corals can't even survive anymore because they're used to that shallow, clean water environment, marine environment. And once the water level continues to rise above a certain point, they were speaking a lot about thresholds. Once the water level gets above a certain threshold, those corals are just not going to be able to survive among other marine life. Um, and I mean, even not just, wildlife and all that, rising water levels are playing a big part in the destruction of human lives as well. Infrastructure that's built right on the coast. If this water continues to rise, then a lot of the infrastructure and livelihoods of a lot of people that live straight on the coast, it's going to be destroyed, and they're going to have to move further inland and find new homes and relocate, just like animals would have to. And then, like I said, drier climates, it's only natural that if the planet heats up more and more, there's going to be drier climates, there's going to be less water, excuse me, less precipitation. And so, you know, I'd say the biggest focus that I took away from this paper was 100%, how can we slow down the process of climate change, because it's been sped up so much by humans already that we need to, you know, as a whole and as take initiative and finally, sit down and discuss, okay, what are some clean and efficient ways that we're able to, kind of slow down this process and recycle these greenhouse gases to make sure that, we're, doing our part and not harming terrestrial and marine biomes as much as we have already. So that's my presentation, and thank you for watching.